Can you solve a long division problem where almost all the digits have disappeared? Welcome back to Maths Unleashed. Today we are going to try solve this puzzle using logic, not guessing. Before we start, let's quickly remind ourselves of 4 key terms. The divisor is the number we divide by. The dividend is the number being divided. The quotient is the result of the division, written at the top in long division. The remainder is the amount left over at the end, if the division does not divide exactly. Now let's take a look at the puzzle. Here we have a 1-digit divisor, a 3-digit dividend ending in 0, a 3-digit quotient, and a final remainder of 1. Before I start solving it, pause the video and see how many digits you can work out yourself. The first thing we can do to fill this puzzle in is to understand how this long division works. We know that this 0 will slide down to this place, so we know that this must be 0 because that's just how a long division works. If this is a 0, this must be a 9 because this subtraction has a result of 1. This number is the result of the divisor times the last digit of the quotient. So we know that something ending in a 9 must be the product of 2 numbers. Let's list all the 2-digit numbers ending in 9. These are 19, 29, 39, 49, 59, 69, 79, 89, and 99. We know that one of them has to be the product of 2 digits, the last digit of the quotient and the divisor. 19 is prime, so it can't be 19. 29 is also prime. 39 can only be made by multiplying 13 and 3. However, 13 isn't a digit, so it can't be the divisor or the last digits of the quotient, so 39 doesn't work. 49 can be made from 7 times 7, so this would work. 59 is prime. 69 is 3 times 23. 23 is not a digit, so again 69 doesn't work. Both 79 and 89 are prime. 99 can only be made through 9 times 11. However, 11 is not a digit, so 99 doesn't work. This means 49 is the only one that works. So this must be 49, the divisor must be 7, and the last digit of the quotient is also 7. So something take away 49 is equal to 1. This must be 50. So now we already know 6 of the digits. The next thing we know is that this number take away this number gives us a 5. This means this must be a 6. We also know that this number must be a multiple of 7 because 7 times the second digit of the quotient gives us this number. Let's list the multiples of 7. We can stop here because the others will be more than 2 digits and we know our number is a 2-digit answer. The only one that ends in a 1 is either 21 or 91. 21 is 7 times 3, and both of them are digits. 91 is 7 times 13. However, 13 is not a digit, so we know that it has to be a 3 here, a 2 here, and a 2 here. Otherwise, we have to put 13 here, but that doesn't work. We also know that if this number slided down to get the 6, that means this must be a 6. Now we only need to find out 3 more digits. We know that the divisor 7 times this number was equal to a digit that we would put here. The only 1-digit multiple of 7 is 7. This means this must be a 1. It can't be any more than a 1 because if it was 2, then this would be 14 and wouldn't work. So something minus 7 equals 2. So this means this must be 9. This is our final solution to this problem, but we should check. 7 times 137 gives us 959. That means 960 divided by 7 would give us our remainder of 1. Write in the comments below and let me know how difficult or easy you found this question and how many digits you could fill in by yourself. See you next time!